dear participants of the distance education on using our EduSat facility, and many of you, I know that you are also getting on through the AView. And this topic, this year we started on the applications, because every year we are having the lectures on the basics of remote sensing, GIS, GNSS and digital image processing. And I hope you all are also aware we have also an e-learning program which best of the graphics and the audio is also available for you to do it on internet. While we are now going to the applications, I was requested to make the first presentation on natural resource management. So here I will take you to a flair of applications, but most of the details will be given by my colleagues on when we talk about each application for groundwater or surface water. But I thought you all also have to know how our Indian satellite systems have been optimized for our needs, for the users of the requirement. So as an application scientist, what I have gained experience, I would like to share with you on this particular exercise. So in the geospatial technologies, when we speak, remote sensing is one of it. That is on the Earth observation systems which are there, and you are all well aware of different spatial and temporal resolutions which are existing. And then how do we convert this data into information in GIS? And GPS is an added data which we get today through a separate instrument or through the mobiles what people use. And more today we have automatic weather stations, and also there are a lot of sensors which have been kept at different isolated locations as the point information comes in. And today crowdsourcing also has become a very important aspect of data collection process, that too in geospatial environment. And how do you use all this information into modeling and decision making with knowledge? That is a challenge. And here we are talking about remote sensing, but there are so many other tools of remote sensing like LiDAR or handheld or aerial vis-a-vis, and also the microwave remote sensing, etc., which we'll go and discuss in the subsequent slides. Now coming to, we have a host of Earth observation imaging capability, both from sun synchronous as well as geostationary. I am not going to the details because many of you are familiar with the different type of data products where it is available and of different resolutions. So when the resolution is coarser, we get very temporal resolution is much faster, but when the resolution becomes more and more finer, the temporal resolution may be less unless we have a contemporary satellites which gives it information. But since the data at a periodic interval for a country like India is very must, and that too whenever we have the cloud, we need continuous imaging. So presuming the cloud moves, so we get the image of the Earth. So that's where we have on geostationary platform also we have various satellites, one for remote sensing, another one for also the meteorological observations, and many parameters which are useful for the cloud profiling, etc., that which happens in geostation satellites. I mean, in future we'll also have a GeoHR, that means from a geostation satellite in imaging and remote sensing, which is also possible. And at NRSC we have also the LiDAR, aerial LiDAR, ALTM what we call, and also the hyperspectral remote sensing is also on aircraft. It is being experimented, and we'll have our own satellite. We had previously one payload called IMS, we also had from Indian satellites. I want you all little focus on few things. Most of the time whenever we talk about a resolution, we are always carried about by the spatial resolution. That means if it is something like 23 meters or 56 meters, we presume that certain features smaller than that may not be deciphered. But maintaining the MTF and the point spread function of the payloads what we do have, we get best of the images that is in the IRS products. I request you to kindly focus on to these two images, which is the first one appears a little coarser, but whatever the smallest features which are there, including the water bodies or the road network, which is from 56 meters what you're seeing on the top. The second one is 23 meters. Everything what is there in 23 meters is also visible and also detected. However, to only it is little blurred, so a certain amount of image processing principles, or if you have a database at 23 meters, monitoring at 56 meters, it becomes easier. And then the advantage of it is it covers a large swath. That means we can cover almost a particular state every fifth day, and that is a coverage what normally you cannot get at 23 meters in LIS3 data, or whenever you go to high resolutions of 5.8 meters. So you should be very conscious that It is not that only at 56 meter resolution the data will not pick up the smallest. The smallest of the water bodies also is possible to pick up at 56 meters because the contrast is good and also MTF of these payloads is much better. And even whenever we talk about a continuity of data, we also should look at always the spatial resolution of remote sensing data in terms of uniformity and spectral resolution. At whatever you are seeing at 5.6 meters is also available at 56 meters. That means once in some of the passes where we need detailed data at 24 meters, even is not available, but to continue to see that crop growth profile can be monitored at 56 meters. So you should always explore whenever you are doing some research or certain studies. Don't get disheartened if you don't get 5.6 meters, but also you have 24 and 56, a continuity of data whenever we have cloud cover, and whenever the high resolution data is limited, we can also use coarser resolution. And this is how today we have also a natural color composite. This is how NRSC supplies the data. Such a large area is covered in one shot of ResourceAt2, one of the best data sets where for any of the natural resources management, I feel this is one good beginning to start with. Similarly, we also should extensively use the shortwave infrared besides the infrared which we are used to making a color composites. You may kindly see on the left image the floodplain is not very explicit except for certain moisture zone here, but when we apply the shortwave infrared, the width in which the moisture zonation is available comes out very clearly, and similarly where there is no moisture at all, especially what we call as pediments, may not have come very clearly here, comes out very clearly here. That means this is cut rock surfaces. If you are making a pipeline alignments or canals or anything which is you have to do, it is as good as blasting a rock. That means the cost estimates becomes totally different than the normal area. When you go into the field, you will find some thin veneer of soil, but then actually when you start digging it, it's a hard rock where you have to do a blasting like a because it's a residual remnant. And we have best of the resolutions, ResourceAt1 and Cartosat. You have best of the mosaics. This is an image of UN city in Vienna, where we can see all the IAEA and also the UNOSA buildings per se. Next, because there may be some of the specialists who are all looking at today in the remote sensing applications, some of you are maybe professionals, some of you are maybe started the interpretation. So there's a varied type of groups. There may be geographers, social scientists, geologists, or some agriculture people. But to make people, there are 2-3 things which we should know. That there is, whenever there's a hard rock, when it moves, it is tend to break, and when it breaks, it calls as what is called fractures. That means this is more vulnerable for erosion compared to the adjoining areas. When it is more vulnerable for weathering, means when weathering happens, the moisture retention will be much higher here in this area which you are seeing linearly as red than the adjoining areas. When the moisture retention is more, then the tendency to the natural vegetation to grow becomes better. And also if you go widen, maybe the people must have put some bore wells and doing some irrigation. But you also kindly see these fractures are not only in one direction, but also they can get right angle, and then you can see this water body which has been locked here is also dragged onto this side. So you can see almost like a rectangular type of a drainage in this. And also kindly note, there are certain features like a dark dolerite dike here. So the dikes also exist where they go under the surface, and then when you tap for groundwater, the resources on one direction may not be the other. So this is a very simple way of looking at, but then this is a reconnaissance survey. Whenever you do any natural resources survey, we should have a reconnaissance survey. That's where the AWIPS data will be very useful for such reconnaissance survey. Then we go into the details. But when you go into the details, the things can get diffused. The same fracture zone, what you are looking at, got diffused because people are taking agriculture, and this agriculture is putting some bore wells. And here also there is another zone which is located here, and the dikes, the small rock outcrops keep coming, so it gets diffused. So always it is for any natural resource management, we have to go for a larger area so that you need a coarser resolution. Then we go a little finer resolution. This is what the data is also organized in Bhuvan. You can look at coarser, and also you can go for finer resolutions. And the features which has been marked here will be more detailedly explained to you when people speak to you about groundwater mapping. And this is how under the natural resources management, so many layers has been continuously being mapped under NR census. So we have on forest cover, which is being done by FSI. Wasteland map has been done by NRSC with all the partner institutions, that is the state remote sensing centers, and other layers like 250,000 scale This is every year this data has been generated. At 50,000 scale, once in 5 years it is being generated. Now the next cycle, the new cycle data is being uploaded onto Bowen. I request you all kindly see for these layers. The land degradation at 50,000 scale is again completed. Then snow and glaciers, the soils with the other partner institution of soil and land use survey institution. Then geomorphology with the GSI, it has also been completed. And then the vegetation type and also the wetlands which is coming from which is available at 50,000 scale. Now the ministries, various ministries also invested or taken up certain projects by themselves with their own self-funding. That's on groundwater prospects which I was telling you, or the wasteland, that is Ministry of Rural Development, the urban development on National Urban Information Systems, and on water resources ministry also has an excellent database called India Wadis, which is now in the public domain. I request you all to kindly go into this data set, kindly see how the data set is organized. And for crop, Ministry of Agriculture has its own institute now, Mahanapolis National Center for Crop Forecasting. So they do for around 12 major crops and also 2 horticulture crops like potato and other crops. And then also we have on disaster related the information. There's a control rooms today available at each of the states, and continuously this information on disaster also keeps moving to them. The environment and forest and the mineral exploration today, the remote sensing and GIS and modeling is extensively used, and agencies like NMDC, MECL and even the private institutions are extensively using for mineral exploration. Then we have the other applications which comes from special users too. Then there are believing such applications. I thought I will tell you some flavors. People may have questions whether is remote sensing is only for a societal benefit. It is not so. There are certain centers of the states which also invested their money into developing their own GIS projects without much of support from an NRMS, etc. This is a state-funded project totally. What you are seeing here called Chhattisgarh GIS. They invested something like 20 crores and they got certain money of 10,000 each in 2 financial years, and they have entrusted the job to the regional center in Nagpur with which is under NRSC today, to develop on natural resource database, road information and georeferencing of all the cadastral maps. Because you'll all agree with me that remote sensing, when you talk about natural resource management, we go and look at up to the application where it can extend. But then most of the schemes in the government, what will be implemented by the states, is all beneficiary oriented schemes. When you want to have a beneficiary oriented scheme to be formulated, we need to clearly know who owns the land. Is it from a government land or a private land? If so, what is the status of the farm? Is it a small farmer, marginal farmer, a large farmer, or the landless laborer which are available there for whom a work has to be created? So to have such an information, these are the layers which was suggested to be put through with a financial outlay, and which was completed in a matter of 2 years successfully with the support of the industry and also many other organizations. One, if you see here, a georeferencing of cadastral maps is also one of the activities which is taken. Today most of the states are also doing this because the cadastral maps doesn't have latitude longitude. So to bring latitude longitude, the digital maps, which are the maps which are available in analog form, have been scanned and a procedure has been put. You may kindly go into the DOLR website, Government of India, which also gives you a clear picture on not only the digitization of cadastral maps but also the georeferencing, and also subsequently doing the land records for a conclusive title, how you can use alternate technologies either by field surveys, aerial surveys, or where we can do satellite images has been clearly mentioned in that. So here the digitized cadastral maps are georeferenced, giving control points onto the satellite data, and the legend is being mapped by the land records department, and there are a lot of quality check procedures are also mentioned at each stage and which has to be followed like an industry. Today this is for Chhattisgarh which has been mentioned, but the states like Maharashtra, Gujarat, Karnataka have already completed under various projects where there is a partial funding from ISRO in terms of the technical support or from but this is mostly done by the industry with the support of the industry. And now today many states like Haryana, Madhya Pradesh and West Bengal and Andhra Pradesh, or all other states also have picked up and they are trying to accomplish this task. Once we do this, we have a cadastral map overlaid onto a satellite data, and also the satellite image derived information is also available as a seamless mode where we can make a number of projects beneficiary oriented. While having this, there are also certain other projects which has been done having the state government's requirements of Chhattisgarh, the cadastral maps are available as Chaturasima maps. Whenever a farmer would like to go for a loan for every year to show his proof of land ownership. These softwares were developed on Linux as well as in Windows and placed on small machines which are on the on a pilot basis at that time, where the land records department wanted at the school where the Indira Shakti Suchna Kendras, where computer literacy is given to the girl students from 8th to 10th standards. On their machines, this data was operationalized for 3 talukas in Chhattisgarh, and also the NIC data also is linked. Today, having come to this stage, and this is a government which has decided the format, and this is what the printout which will come, and then the headmaster signature was authorized to be given here in the initial stages. But today, this can be an online information which can come through the net itself to the different banks to know who owns the land, how much is the area and its tenement. And while doing such exercises, this may not be a part of remote sensing, but you also should be very clear, whenever we are doing remote sensing based natural resources management, we may have a lot of spin-offs which will come, and this is one of such spin-off. And while keeping it on, putting on top of the satellite data, it becomes clear survey number wise what it is natural resources, strengths and weaknesses in terms of the slope or the limitations. What I mean weaknesses, the groundwater potential, and what alternate land uses can be made. So there are certain few packages which has been developed by ISRO and given to the institutions. Similarly, the state, while developing this database, they could very effectively use for identifying alternate sites or suitable sites for horticulture, suitable sites for new industry development, and also the new township of the Raipur township has been extensively used this database to identify the new township which is coming. Naya Raipur city, the new capital of Chhattisgarh, is based on that, and also the town planning of most of the small towns, they have used these data sets for their planning purposes. One example which also I'll tell you is the power transmission lines for Hyderabad, say the Chhattisgarh electricity board. This particular exercise is needed in a very short time, and for 1000 kilometers, if you have to do this kind of a work in different reaches, maybe around 200 kilometers or so, it will take minimum 2 years. But here the chief engineer himself and his few of his colleagues, within 10 working days, they could cull out all the corridors of for 1000 kilometers in different reaches in 10 working days using certain criteria, and also how it will go through the environmental ministry's considerations when you make certain power transmission lines of it, and nearness to the road, and all these conditions were prevailed upon. So through GIS analysis, without endangering much of the environment and ecology, how you can make a best corridor is possible using these tools and techniques. And I want to bring to your kind notice for future research areas where you have to look in. For example, in this slide, if you are able to see, these orange boundaries is all the cadastral maps overlaid on the satellite data. We have put in a little coarser resolution so that you can see more number of villages. The pink is another village, the green is another village, white is another village. Okay, but when you georeference, they exactly match well. And then secondly, there are some lands which are hanging. Is the land holes are up to here. There can be some accretion or erosion at certain places. So some people may lose land, some people may gain land, but may not be updated in the records. Which also we had some exercises in Maharashtra to happen. But I will request you to kindly draw your attention here. You can see this curvilinear village boundaries or the survey numbers which are going like a meander. And these are small white dots is also small village which is located here. That means this river was here and subsequently it moved. And you can also see the sandbars which are located here in each of these villages gives the sandy texture here. That means there is only flat channel, but there is no paleo channel. But here this is a paleo channel. That means if we are making a road, here in a Pradhan Mantri Gram Sadak Yojana, etc., that we have to make a culvert. So the moisture moves and it doesn't get polluted because it is shallow in nature. And these are also paleo channels are very important when you are looking for certain placer deposits. That means that the source of a gold, source of a diamond is somewhere else. And if you want to search, it is not the active dynamic stream what we look at, but also these paleo channels are very important. For example, for in many cases, we have so many such examples which also can be found out from the geophysical surveys or also using from ground penetrating radar because it is shallow in nature. And then you can also kindly see how do we have to handle this on an image. This is also in part of Bilaspur district. You may see here in the central India, majority of the part of the country, we have natural springs. The spring water is collected into small tanks, and from the tanks, moisture moves down perennially, and then that's where the hill stream beds are widened and agriculture is taken. And here these are called also the zoro cultivation. Well, the moisture is moving here. Whenever we make railway alignments or roads, we ignore such. So this is where you can see the moisture and the water itself is accumulating. That means there is a point of failure can happen when heavy rains or flash flood will come. So you have to leave the moisture to go. So many of the time in deltas, etc., the floods, there are floods, but also the water doesn't get drained faster because we don't take these into consideration, or the span of the bridge when we talk about the paleo channels, etc., which only the satellite image will give you such information. Having put on the cadastral overlays and know about the people, we can conduct meetings, village meetings, along with the locally elected bodies. For example, this lady is the Gram Panchayat president of that particular village, and you will also appreciate today majority of the villages, the Gram Panchayat presidents are ladies. And then you can see some of the night time when you conduct a meeting, you will have more audience because in the daytime they have work. So if you want to conduct or communicate with people, ideal situation will be in the night, where not only the gents but also the ladies, children, everyone will participate, and it is up to us to convey how such methods of natural resources management like watershed programs or integrated or Narega or Pradhan Mantri Gram Sadak Yojana, whichever scheme which is available for the benefit of the people, how it will make them economically stronger, and resource management, how they will make sustainability better, is what we can communicate. So this is where the village meetings which has been conducted at many places. Having understood, to go to that level, that's in ISRO allowing under an anonymous program has started a major program called Space-Based Information System for Decentralized Planning. I request you all to kindly go to the Bhuvan website. There is also called Bhuvan Panchayat, in which how this information which is being done at 10,000 scale. The first one, we said that we will also have one ortho-corrected high-resolution satellite image of a Cartosat and LIS4. This has been done by many of the state remote sensing centers have participated in doing, and distributedly with the support of the regional centers of ISRO and other space institutions. Parallelly, we could do the whole country, and also a manpower of around 300 people on satellite photogrammetry could be trained, and with a state level block adjusted at 2-meter resolution of X, Y and Z could be generated. But you can see the volume of work is so large, that means these orthocorrected images, almost like for UP, comes somewhere around 650 Carto1 stereo pairs. So this kind of a mammoth task was not done. I didn't see any report across the world. Such kind of an ortho correction data has been done from the satellite base, and today it has been done in our country, and then it is available. What does it mean when we generate a DEM and an ortho corrected at this resolution of 2 meter, better than 2 meter of X, Y, Z, which is controlled at a state level? You can get such kind of natural images. Kindly see here, this is all downloaded from Bhuvan. This is not a data which I put on my machine. And you can see all the nice trees and also each of the sheds, and also you can see the finer continuous contour trenches which have been there, and the vegetation on top of it. There is a part of Beamtal, and also the 3D views which you can do because it's a DEM available under Bhuvan, where you can make some snapshots. And having such kind of a voluminous data, as I told you, on natural resources which is available, previously whenever a project we used to define, it used to take a 75% of a project time for data collection and data conversion. Then the attribute tagging, which will take 10 to 15%, and 5% is left only for analysis. But today, most of the data is available in distributed data servers, either from IMD, either from MOSDoc, or from ISRO, and Bhuvan, NRSC, and also from we also India Wadis. So many of these sensors, all these data sets are available, and where conversion becomes easier. Attribute tagging, what takes around 10 to 15% time, depending on the project specific information which you gather. But for spatial analysis, you will have ample time to make certain alternate analysis per se. And then we have similarly, when we claim such, there's a request came from the erstwhile planning commission on how we can make for a plan for Jharkhand state, and we can see here there are illiteracy is higher, and then we have a population which has to be also to be addressed, to give certain priorities for economically and socially weaker section. Water is quite plenty, natural resources very good, mineral resources very good, and also agriculture, but here only the cropping intensity is quite less in this particular area, and yields are also quite low. That means there's a good opportunity for the government to invest on the developmental programs, especially from natural resource management and conservation like IWMP or NREGA. And this tells us not only the Kharif and the single cropped areas are quite large, fallows and the single cropped areas. That means to bring a better cropping intensity, the government schemes can be effectively used. And also the sheet erosion, that means the topsoil is going away, and this came from the land degradation information. That means restoring this is also will become a very important aspect what we have to look for. That means the government has ample opportunities to give very developmental schemes from natural resource management. And with the data, there are certain methods available. What is available with the Soil Conservation Institute, the SES equations which has been looked in, and micro watershed wise, the hydrological groups were done, and also the hydrological modeling to ensure that what type of water resources plan can be done, where the check dams or the percolation tanks or the farm ponds with lining and without lining comes out clearly in terms of the donation per each village, and the canastal and what is the alternate land uses can be done. When we talk about agro-horticulture, we are very specific on mango, lychee, what is the type depending upon the soil texture and its composition. And also putting on the canastal overlay, it becomes very clearly to see each of the where is the sheet erosion, where is the village, and where is these farm boundaries or the parcel numbers. I request you all, while talking about when we talk about natural resource management and whenever we do any study, we also should be clear how much of the field investigation we ourselves have carried and how much of the local wisdom we try to observe. This is most important whenever we talk about certain prescriptions which should be given. You may kindly see here this particular zone which is in this moist zone in this color is all 1 to 3%, is less than 1% slope. So people made their field burns in such that moisture will keep moving. When it is 1 to 3%, the field burns have changed, their aspect has changed. When 3 to 5%, it is something else. That means they know exactly how the incidence angle falls on this particular slope in different parts of the season, and when the crop, the leaf will get the best sunlight for making its energy conversion, and the process in which it will produce will be better. And this is local wisdom. So we have to really appreciate how people at the time made the field burns and the shape of the features and their geometry of those. And this is 5 to 8% where you have the forest type of an agriculture. And then, but without knowing these moisture zones, if you make a road of this nature under Pradhan Mantri Gram Sadak Yojana, the moisture doesn't go the other side. Then we'll have the extension workers will have a difficulty. That means what the wells in the village here are not getting sufficient recharge, and the recharge levels will go down and it will have a negative impact. So this gives an opportunity to look in whenever we're doing certain actions, we are not hindering the development or the natural process which exists. And this is where there's a possibility of having shifting dunes. This is on Tosham area. You can see the sandy texture. The protection is mostly on the roads, but not much here. So there is a chance of shifting sand dunes can take place very effectively here. So that means one of the job of watershed program or soil conservation is to look in how you can make different corridors of wind control. And also the actions what has been done becomes, you may kindly observe all this information has been downloaded for Bowen. So you can go into Bowen and explore for yourself your village or the adjoining villages or your project area. Here where the paddy bunding has been systematically done, the moisture retention is best. Where it is not done properly, you can see on the down what is the streams or the small tanks, how fast their sediment is yielding. That means the information is becoming much and much simpler. That means in a single village you are able to see a percolation tank, but the catchment of it has not been treated properly, so silted faster. Or wherever there is a treatment, it gives an image. That means seeing is believing. So communicating to the farmers or the villagers in terms of natural resource management becomes very clearer on the subject what we are looking at. And it also is possible, you can see where there is a shallow soils and where there is a deep soils or a moderate soils from a natural color composite which is put in Bowen. You can see such image. This is part of Maharashtra where you can see, and some of these continuous contour trenches where there is vegetation and there is no vegetation comes out very clearly, and this can be zoomed to one more level which we can put it through. So kindly don't just believe on the resolution. The resolution 2.5 meters, what I have shown, many of these images are 2.5 meters of Cartosat 1. This is a stable platform with a metric camera, and then there is an ortho-corrected images, and best of the resource at list 4 has been merged to give a natural color composite. I request you all to kindly explore these images first, then asking for multiple data, because the higher the resolution, the swath becomes smaller. That means taluka of 1000 square kilometers, you have to stitch more than 10 to 15 scenes if you want to have a high resolution. Here it is 27 kilometers is the swath, so hardly it is 3 or to 4 scenes you are able to cover the taluka what we are talking about 1000 square kilometers in majority of the country of India today. And this is where certain along with Professor M.S. Swaminathan, some examples where the farmer suicide has happened to farmers empowerment for the ladies. Programs have been conducted on similar lines. This in Maharashtra, and there are certain government has taken in Maharashtra. They have given some government orders that whenever there is a compensation to be paid when there is a disaster for the crops, they use the georeferenced images and the satellite images of the latest to identify which survey numbers got affected, and accordingly the money is being distributed. I hope this will effectively go in all the states in a continuous manner. Or when there's a government has to look in how the best of the area to be identified for rationalizing the Great Indian Bustard Sanctuary boundaries, they are effectively used for remote sensing and GIS, and this has also helped the Supreme Court to give a decision on the best of the analysis has proved right to ensure that to give a direction to the state government how they have to follow when they make a sanctuary boundaries using the remote sensing and GIS analysis. You will be hearing these kind of examples in much more details. I am giving an overall picture of so. And this is one example where for an IFCO from the regional centers at that time has been asked to give a model to the fertilizer demand and fertilizer for the marketing related services. So from the natural resources module, it has been identified what is the potential fertilizer demand, and this keeps improving depending upon the soil samples which have been analyzed. And here extensively the information what is published by NBS and LUP in terms of the maps has been used, and a package has been called as GeoFarms and been implemented with IFCO. And then there is a weather module which tells what is the rain when it started in the for rain-fed agriculture, and how the crop growing period has shifted if there is a change in the normal rains. And then the logistic modules tells about where the warehouses are there and how the information has to go to different sale points, etc. like that. And this entire thing is made as an available package, and this logistic module allows you to do a proper allocation, and also the routing of the vehicles can also be planned, and this entire module has been capacity built and handed over to them. That means an end-to-end application can be done. This is one example which has been done by our colleagues from Jodhpur. This is where they made a package and implemented in Kazakhstan. They are using as a soil moisture which comes from the microwave remote sensing data to understand what are the potential areas, keeping certain static layers like soil texture, landforms and land use, but dynamic layer like soil moisture and vegetation density, which can be monitored from microwave remote sensing here, and then from the optical remote sensing, and how we can tell which are the potential sites for identifying the locust breeding grounds and optimal period for breeding. These also are worked out and made available. You can see this insect, how it puts its tail and then measures various parameters including the temperature, soil moisture, etc. that. And then a life cycle builder also has been built because this is what is possible in GIS. So depending upon the stage, what is the type of method for eradication of such purposes also can be planned. So this is implemented in Kazakhstan. So it is on the imagination. Your perception is the limit. Today with the data available, we can many more examples. This is one what has been done for an indigenously web-enabled DSS for Kalpakam. They wanted to have a nuclear emergency response system. Whenever there is any leakage or anything happens of the radiation, how you can measure, how you can find out, and how people can plan themselves in making certain mechanism. This is a simulation which are shown, because there is a static PDF, you are unable to get that feel, but there is an online system which is now being managed by Kalpakam Research Institute, and it tells in the next 48 hours how the wind plume will move into the ocean and how it will come to the land. So you will get some time. These are all blue boundaries or the village boundaries, and different type of dosages depending upon the intensity of exposure is also mapped, and it also has information on where the hospitals, etc. that are there. But for modeling, the information on the vegetation fractals, etc. has been used. And in future, you need to do a lot of simulations, as I mentioned to you. The modeling will give you a different time frames of how the either the water flow or a flood flow will happen, and the simulation models will be effective methods in going to the people and explaining if the natural resources are not conserved, whatever repercussions can come either tomorrow or in future, and what are the best land use practices people can adopt to. So this is one method which you should adopt now, how you can make different scenarios using modeling go to the people. And I request you all to go to the Bhuvan, the gateway for EVO products and services of from NRSC of ISRO. So there are 2D and 3D products and Bhuvan, mobile Bhuvan. You will be hearing more about it, and what all the examples which are shown or the data is put from acquired from that, and these are the type of resolutions of the data where some of the things are available free, some of the things which you have to put through. And here today we also are integrating the mobile is becoming a very simple instrument. It also is like a remote sensing. It has an imaging, it has communication, it has navigation, so you can exactly pinpoint its location of time, and the location tagging can be done. You can see here this background is a detailed information, whereas there is a cursor image, and the information what is there here you are able to see a field boundary, a farmer who has been given certain funding for fodder cultivation, and the farmer is also photographed along with this, and also the image exactly tells you. So a precision may not be needed when you are looking at monitoring, but the crowdsourcing will help you in giving the precise location what people have done, and this has been extensively used when but we also have to be cautious when the plantations, when the canopy is not clear, it may not reflect in the image, so it will take some time to get reflected onto the image. And for urban, there are many other examples which could be done. There are a lot of town planning and other exercises which my colleagues will be. Mr. Raju must have put certain urban related applications is a special thing which will be coming in. But my emphasis on the database what is available on NUS today, NRSC along with the Ministry of Urban Development, and ensure that is overlaid onto Bhuvan, and any updation features tools have been provided. So this what I am showing to you a common is already done by the town planners. This is not done by any remote sensing expert, but these are the capacity built into the town planning department, and also the field data which is collected through a mobile has also been linked to see what is the development plan, superimposed onto a satellite image, and observe the latest changes which has happened, and the field information is integrated, and a projection is done in terms of a master plan, how the future for the next 10 years has been done by them. And a lot of capacity building programs have taken place for the town planners across the country at different institutions with the support of the state remote sensing centers. And this is how the GIS map is published into Bhuvan, where people can give their suggestions for the maps to happen. And today we have a lot of low cost alternatives of 3D modeling, and this can be done either with the metric camera, very precise, or you can with the laser, or you can also with handheld lidar, what you mean, and also with the mobile cameras. So certain examples to do if you want to do your own 3D imaging like this, we have made in IRS, we made a package called Trivium, and the Trivium will be available on IRS website, where you can download, take your own photographs of with the overlap, certain overlap with the guidelines will be given, and make your own 3Ds for close range photogrammetry and put it on. This is on Bhuvan. We have kept these images, and where you can do the editing of the features and add attribute table in terms of how many people exist there or what type of infrastructure, and you can use it for planning for various applications. And similar type of thing we have used when we had the Uttarakhand disaster, using a crowdsourcing with the local students. With a small instrument of 8,000 rupees, how we could train an M number of students, around 120 students from 3 different universities and the faculty, and they could bring out more than 20,000 points and in a short time. And the details of the data is available here. This was possible to again reinterpret some of the potential zones of landslides, or where the intensity has changed, where is the field experience on either in landslides or on the buildings which are broke up, or the bridges which are given away. And in future, you can see from satellite data, today we are at an example with using the C-band and L-band interferometric sound. Initially it was been experimented in Zaria coalfields, where the subsidence is very clear surfacially. The rate of change, where it is high, the L-band has given good image information, and C-band where the rate of change is less. And today we are doing this kind of research with CGWB on looking at the northern part of the country, central Delhi, etc., where the overdraft of groundwater is happening. It's also visible from the GRACE images, but with satellite interferometry, we're trying to look at how the depletion rates in terms of centimeters is going to be measured. So in the past we had pictures and many other things as a web portals which are static in nature, but today they are more of a dynamic in nature, and we have the web portals which serve continuously sensor derived data, and this becomes one of the main method for us to do certain modeling and certain simulations and virtual reality. And then the changing emphasis is on, we are talking about up to time, but then we have many other things like pressure, texture, temperature, sound. Anything can be now recorded, modeled and simulated in the environment. But most importantly, kindly my friends, you have to see the participatory GIS, the public as a planner, because we are in a democratic country. The people has to accept the plans what we make from the best of the sophisticated satellite images. This makes the plan acceptable. It can be monitored, and also we can see what are the economical gains, which is economically what are the gains people have made in the particular region. And this is a challenge. And today, as I've shown you many examples, the satellite images have become more simpler in terms of the optical. I didn't touch much of on the microwave and other things as the first example, but even the microwave data analysis today is becoming more and more user friendly. Yes, today the EO and in situ observations is made free or made available, people to access and do their own up to the panchayat level plans and constitutional amendments which are there. That means the planning is either at the village or the gram panchayat, or it has a local bodies when you talk about urban. There are different policies which made the data made available free or made accessible for the people for a particular cost. Or there are different programs like NNRMS or NRDB, NSDA or Disaster Emergency Management, National Database for Emergency Management, or BHUVAN. But then the developmental programs is one actually takes the data. When we talk about the watershed program or rural employment guarantee scheme, Pradhan Mantri Gram Sadak Yojana or NLRMP, Land Records Modernization Program, and Healthfort and Hill Area Development Programs, etc. But other part, what needs more emphasis today is on crop insurance, other insurance, or the facility management, what we call as automated mapping and facility management, AMFM, what is called. And the capacity building, yes, it's always has its own charm, and there's a lot of potential for this to take, because one is at the awareness level, secondly becoming specialized, getting certified, and you be on your own and do a task. And we have in the future, we have many more satellites which are going to come. So there's a continuity of the programs of ISRO which are planned, and then you'll have a best of the satellites besides either for imaging or for non-imaging satellites for you to take up. But the one part what you look at, whatever information you are generating from this remote sensing data should be as sweet as this nectar. The complexities of the data analysis and its information analysis must be left to be at the background, and this analysis will give you more user base, more user acceptability, and more effective use of these tools and technologies, not only for mapping but monitoring and modeling, and also making the better life or a quality of life for peoples to come. Thank you for this opportunity.